Hello, in this video I will go through an example of running a model inside the SMARTree client. In this particular example I'm going to run a micromechanics model, which is a model that will predict the properties, the effective properties of a fiber and matrix when combined in a composite form. And this video will just show you how to pull up that model and how to execute that model. So one of the features of the SMARTree platform is that you can actually run models embedded directly within the client tree. So there's no need to create any type of separate tree. You can basically just utilize the SMARTree templates as provided from the GitLab site and execute those directly. Within this library, there's also a wide variety of fibers and resins from which one can use as well. So they're all tied together through the smart tag concept. I have another video, separate video that talks about how the smart tag concept works, and I won't go through that here. But the one thing I will point out is that the client is built so it establishes relationships between units, properties, materials, and in this case, a model. So the other video on the SMARTree channel, YouTube channel, talks about how these are all connected. There's a separate tree for units. There's a tree that describes properties. These properties are used to find these properties within material trees, of which there are a host of materials provided. And the tree that I'm going to pull up now is a simple model, in this case a micromechanics model. And the client does all the hard work of grabbing all these properties and the units associated with those, and then running those inside a model tree. So what I'm going to do now is I'm going to pull up a particular model, a micromechanics model. You can find it in the libraries here, or you can actually use the search feature, which is quite nice, and you can type in a few letters to describe what you're looking for, in this case micro. So here are some micromechanics model in here as well. You can also type in model, and it will find various models. And so in this case we're looking for micromechanics, and here's one right here, and I'm just going to pull it in. And this model, as I said, these models and model templates are pre-built models, which means you don't have to build a tree. The trees are already here. They're organized in this particular instance. Typically it has a top section here that describes the model, a model input section. In this case we have a microstructure that's a continuous fiber lamina. We have a fiber we're going to pick from, and we have a resin. And these particular elements right here are tagged elements, which means that it's going to search through all of my SMARTrees over here and find a tag that represents a fiber. So in here you'll see all these fibers. Likewise, for the resin, it looks for the smart tag in here that describes these trees as polymers, and it pulls out these various resin systems right here. So the final piece of information you need is basically the fiber volume fraction, and you can vary that value right here. To execute the model, it's just a matter of going to the Model tab, which is on top. And what you'll see now is you'll see the bottom left here is essentially a model status. What that's telling you is basically the state of the model. So if I run the model, you can run it from here. And what it does is it sifts through this tree and plucks out inputs highlighted in green, outputs highlighted in blue, and results highlighted in light blue. So what it's doing right now is it's actually executing this model. And so to show that it's executing, I can then vary the fiber volume fraction, for instance, and you will see the properties change accordingly. And these are the properties that are predicted by this model right here. You can also change the fiber to a different type of fiber, and you will see the properties change as well. An important point to note here is when you start changing these values, it immediately runs the model and gives you the results. It also immediately checks to make sure that it found that particular material in your library, whether it's the fiber, the matrix. It also lets you know what type of properties it found in those materials. So for instance, for the fiber here, it did find orthotropic materials, and for the epoxy system, it did find isotropic materials. If you're missing some of these values, what the SMARTree client will do is will look in the fiber material to see if there are isotropic properties and use those. And likewise for the resin, although resins are typically isotropic in nature, so it will always just look for isotropic properties. So now you have your model running, and you can actually predict these properties. And what's interesting here is you can actually save this tree as a new material, because you have now created a new set of properties. So when you do so, you can actually hit your SMARTree right here, and you can decide then to save it. So what I'll do is I'll just clear my search. This was a search window. So here's all my materials here again. Click on SMARTree, and now I can save this, as I said, as a new material. So click Save, and I can say, okay, where do I want to put it? I might want to put it under my materials. And here I have a whole host of materials, and I'm just going to create a new folder called Predicted Lamina Material. And in here, I'm going to place that new material. So here it is. And down here, I can give it, it gives it a name by default based on its previous name. I can call it my own carbon. And you may describe, the fiber volume fraction that you used for this particular material. So in this case, it's 60%, approximately 60% fiber. And then you save your tree. So now what you've done now is you've added that material to your library. And now it's scanning everything in there to see where does that material fit in your overall SMARTag architecture, because this material is described, this new material is described as a lamina. And what that means now is you can now use this material in, for instance, a plate analysis. And that I have another video to describe how that is done. So this basically shows you how the micromechanics model works. If you want to execute the model again, you can go back into the model, and it's immediately running again. And it's shown by the color changes. It's also shown down here saying that the model is actually running, which you'll see right here. Thank you.